Hello, fourth grade friends. Welcome to math class, coming to you live from Miss Talisa's house. I first wanted to say that I apologize if there's any dogs barking or cats running around because it's a little crazy here. So I apologize if there's any of that going on in the video. Also, I want to say that I miss you guys. And I hope that you are enjoying this unexpected time with your families, and that you are staying safe, you're staying healthy, and you are practicing your math facts. And if you're able to get an iReady, that's awesome. I know not everyone's able to, which I completely understand. I just want to give a little shout out first before we start to Janaea and Shaq, Chloe, Jaden, Avery, Charlene, Yakeen, Brylan, and Sydney for taking the time to spend some time on iReady working on their math. That's awesome, and it made my teacher heart so happy. So I know it's been a little while, about 2 weeks since we've been at school. So I thought that for our first video, for the first part of this first video, that we would just review the very, very last lesson that we worked on before moving into anything new. And hopefully the light isn't in the way. Sorry if it is. It's rainy out and it's kind of gross. It's dark in here, so I have all the lights on, so that's why there's so many shadows everywhere. So before we left, we were practicing multiplying whole numbers times mixed numbers. And if we remember, and it's okay if we don't because it's been a while, that we use the distributive property to work to solve this problem. And the distributive property means that we are taking this whole number, this 3, and we are equally distributing it. We are sharing it with our whole number from our mixed number and our fraction. So we're going to share our 3 with our 2, and we're going to share our 3 with our 3/7. So the very first thing that we need to do is like we said, we take our 3 times our 2 and we put them in parentheses, because from what we remember, anything that's inside parentheses, that goes together. So we want to make sure that we keep this 3 with this 2. Then we also said that we take that 3 and we multiply it also by our 3/7. And we keep that in parentheses too to remind us that 3 and the 3/7 go together. So as you can see, we distributed our 3 with our 2 and our 3/7. Now, between here, all we have to do is put an addition sign because they go together. We add them together once we figure them out. So we already remember, we've already learned how to solve both these problems. Now we just have to put them together. So our first problem that we have to solve is 3 times 2, which we already know because we've been working on our math facts all year. 3 times 2 is 6. That's right. So all I'm going to do is just write a 6 right here, and I need to remember to drop down my addition sign. Then the next thing that I need to work on, the next part of the problem that I need to solve, is 3 times 3/7. And for those of us who remember, and if you don't, that's okay, we're going to go over it really quickly. We take our whole number, our 3, times our numerator, which is 3. So 3 times 3 is 9. That's correct. That becomes our new numerator. And our denominator is 7 because our denominator stays the same. So right now, my problem is 6 plus 9/7 to figure out what my product or my answer is to my original problem. But let me get a different color. We see this right here. 9/7. Yes, that's a fraction, but my numerator is greater my denominator, the number on the bottom, so that means it's an improper fraction. And looking at it 9/7, I think to myself, that doesn't really mean very much to me. I need to turn that into a mixed number because that helps me visualize or get a better picture. I know you do that in ELA and science and social studies. Visualize and get a better picture of what number that is, of what that means. And we know how to do that by making our handy dandy number bond. So I'm just going to draw the two little legs down here. And because my denominator in my top part of my number bond is 7, I need to make sure that both legs of my number bond have the denominator of 7. So far, so good? All right. Hopefully we can see this. There we go. Okay. So I know that 9/7, because my numerator is greater than my denominator, I know that 9/7 is greater than 1. So there's a whole number hiding in there. I just need to figure out what whole number is hiding in there. And I know that in order to get one whole, I need 7/7. And look at that, I have 9/7. So far, I have enough to make one whole. How many 7s do I need to make 2 wholes? That's right, 14. 14/7 equals 2 because 14 divided by 7 is 2. Remember, fractions are just basically a division problem. But I need 14/7. I only have 9. So, nope. I don't have enough to make 2. But I do have enough to make one whole. So, I'm going to take 7 of those 7s and put them over here. Then I need to think. 7 plus what gives me 9? That's right, 2. Oops. So the second part of my number bond is 2/7. And I can double check this because 7/7 plus 2/7 equals 9/7. So last thing I'm going to do with my number bond, I'm going to change my 7/7 to one whole, and it becomes 1 2/7. Wait. I'm not quite done. I got one more thing to do. I can't forget this 6 all the way up here. So I need to drop it down, and I need to remember to add it to my 1, can't see that, and 2/7. So I take my 6 plus my 1, which gives me 7. And then I just take my 2/7, my fraction, and I add it to my 7. Still can't see that. I'm sorry. So if I bring this all the way back up here to my original equation that I was working on, I see that the product or the answer of 3 times 2 3/7 is 7 2/7. Okay, next we're going to apply this a little bit differently. All right, friends. So, like I said, it's great that we're able to, when we see numbers, whole numbers times mixed numbers, it's great that we're able to multiply them. However, it's even more important that we're able to really apply that into everyday situations. So, the next thing that we were going to do before we left is apply that to word problems. So I have an example word problem right here. Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did her sister run? So the first thing that we need to do, because this is a word problem, we need to figure out the important information, the clues, and figure out what we have to do, even though I kind of already gave you a hint. So looking at this, I know that the really big first important piece of information is this mixed number right here, 2 5/8, because that's how far Tamika ran to begin with. Then I also need to pay attention to this right here, twice. Now, twice, that's not a number, but it represents a number, and it represents and tells us what exactly we have to do to figure out how far her sister ran. So does anybody know what twice means? Yep, twice means we're timesing it by 2. So we're taking how far Tamika ran. Oops, let me get this. Her 2 5/8 miles. And we're timesing it by 2 because we know her sister ran twice as far. Now, look at our equation. Our equation is backwards from the way that we solved the last problem, and that's okay. It just looks a little bit different, but we're still going to get this same exact answer, and that's called the associative property. That means that we can mix our numbers up and we can put them in different orders and we still get the exact same answer, which is different than the distributive property, which is what we're using to solve this problem. But the associative property only works with multiplication and addition. It does not work with subtraction or division. So what I want you to do right now is I want you to pause this video for however long you need to solve this problem. Then when you're ready, I want you to hit play again and we will come back and we'll go step by step and we'll see how you did. Sound good? Okay, go ahead. Okay, welcome back. Let's see how you did. So we know that we have to distribute this whole number, this 2, to our 2 and to our 5/8. And so what that looks like is inside our parentheses, we have our 2 times our 2, and we add it to our 2 times 5/8. So far, so good? Then all we do is we just solve this. 2 times 2 is 4. And we need to figure out what 2 times 5/8 is. 2 times our numerator of 5 gives us 10 over 8. So right now our problem is 4 plus 10 over 8. But wait. What do we notice right here? 10/8 is an improper fraction. And we need to change it to a mixed number. So to do that, I'm just going to do this very quickly. My number bond. I'm going to make sure my denominator stays the same of 8. And I need to figure out what whole number is hiding in this improper fraction. And I know that I can use 8 of those 8s to make one whole. And that leaves me with 2 8s left over because 8 plus 2 equals 10. Let me just finish up my number bond. So my mixed number, instead of 10/8, I have 1 and 2 8s. But I gotta make sure that I remember to add that to my 4. So I take my 4 plus my 1, which gives me 5, and my 2 8s. So how far did Tamika's sister run? Tamika's sister ran 5 2/8 miles. But for those of us who know how to simplify or reduce it, did you get a different answer? if you reduced it, and I'll move it up here, you get 5 1/4. Because we can divide 2 divided by 2, which gives us 1, and 8 divided by 2, which gives us 4. And we know that 2/8 is equal to 1/4. So 5 2/8 is equal to 5 1/4. But if you didn't get that, that's okay, because we didn't really go over that. So how'd we do on this one? Good? Good. Okay. Next, what I'm going to do is I'm just going to show you something real quick. And then we'll be done with this week. Okay. All right, friends. So the very last thing that I just really quickly want to show you or talk about is decimals. Now, we've been doing fractions and understanding that fractions are a part of or a piece of one whole. It's less than one whole. But a skill that you're going to see in 5th grade, so I just wanted to touch upon it and kind of introduce you to it now, because we were supposed to quickly do that when we were finished with fractions, is talking about decimals. So that way when you get to 5th grade, you can say to Miss Winion, oh, wait, I remember we talked about that last year. So up here, I have my tape diagram, which you guys are all used to seeing. And you know that our tape diagram from our left side to our right side is equal to one whole. So I'm just going to label it the way that we have one whole. Now, like I said, we've been working with fractions for a long time. So I took my tape diagram and I broke it up into 10 different pieces or 10 different parts. So that means that each piece or each part is worth 1/10. So then this piece is worth 1/10. So all together, if I took all my tenths together, I have 10 tenths. Okay, good. Just wanted to double check, make sure. Okay, so like I said, we're just going to talk and I'm going to show you that there is another way that we can represent or show the exact same thing, except instead of using fractions, we're just going to write decimals. So what I'm going to do underneath is I'm just going to write a quick little number line starting with 0 and ending with 1, because that's exactly what our tape diagram shows too. This from here to here is one whole. Now I'm going to try my best to make my lines line up with my tape diagram. Okay, so I know that this first part right here is equal to 1/10. This first part right here on my number line is also equal to 1/10 because I split it up into 10 pieces. But like I said, when you write it as a decimal, it looks a little bit different. You write it 0.1, 1/10. That's it. Now, when you write our next number on our number line is going to be 2/10. And we write that 0.2. After 2/10 comes 3/10. And then we have 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 1 whole. So can we see how, even though it looks a little bit different than what we're used to, it is still the same thing. It still represents the exact same thing. Now, one more thing real quick before we go. When we're adding decimals, it's pretty much like you're used to. So let's say we have 2/10 and we add it to 6/10. What is 2/10 plus 6/10? What does that give us? 8/10. And we write that 0.8. 8/10. So 0.8 is equal to 8/10. It represents the same exact amount. It just looks a little bit different. Like I said, I just wanted to give you a real quick introduction into that because that's definitely something you're going to be seeing next year, and it kind of goes with what we're doing right now, fractions. So I'm going to assign you some iReady lessons. I would love if you're able to get on it and to kind of work on those. Next week or the next time I make my video, we are going to work on be introduced to geometry. And some of us in intervention have started that, but now we're really going to start it. So yeah, I hope that you enjoyed this video. I hope that it helped to, help your brain remember some of the stuff that we are working on. Like I said, I miss you guys, and I hope to see you guys soon. Bye.